Good. So now let's talk about adding probabilities. So just now we calculated the probability of the die landing on 1 or 2, and this was equal to 2/6 because there are two possible outcomes corresponding to 1 or 2, namely 1 and 2, and there are 6 total possible outcomes. Now, notice that this expression is the same as the probability of the die landing on 1, which is 1/6, plus the probability of the die landing on 2, which is also 1/6. So in this case, the probability of the event 1 or 2 is equal to the probability of event 1 plus the probability of event 2. Now, it might be natural to think that this rule is true in general, so that for any events A and B, the probability of the event A or B is equal to the probability of A plus the probability of B. And so, is this true? I encourage you to pause the video and really think about this before you proceed, and I'll give you the answer. So we will answer this question now. So consider again the case of a fair die with 6 equally likely outcomes, which I have represented here on the right. Now consider two events A and B, where A is the event that the die lands on an odd number, and so the event A corresponds to outcomes 1, 3, and 5, which I have enclosed here on the right. And let B be the event of the die landing on a number that is greater or equal to 5. And so B corresponds to the outcomes 5 and 6. These are the only two outcomes that are greater or equal than 5. Now we're interested in calculating the probability of A or B. And so the question is whether this is equal to the probability of A plus the probability of B. Now notice that the probability of A is equal to the number of outcomes corresponding to event A, which is 3, right? This is just 1, 3, and 5, divided by the total number of possible outcomes, which is 6. Now the probability of B is given by the number of outcomes that are greater or equal to 5, and there's 2 of them, divided again by 6. And this is equal to 5 over 6. Now, is this correct? Well, I claim that this is wrong because the event A or B corresponds to the following outcomes. So these are the outcomes that are either odd or greater or equal to 5. These are 1, 3, 5, and 6. So these are all the outcomes that are either an odd number or greater or equal to 5. And there's only 4 of them. And so if we calculate the probability of A or B using the definition, what we get is that this should be equal to the number of outcomes corresponding to A or B, which we have just set to be 4, divided by the total number of outcomes, which is 6. And so what we get is 4 divided by 6 instead of 5 divided by 6. And so where did we go wrong in our first calculation? So the probability of A, which we calculated to be 3 divided by 6, essentially counted the number of outcomes corresponding to event A, and there were 3 of them, enclosed in blue. The probability of B, which we calculated to be 2 divided by 6, counted the outcomes corresponding to event B, and there were 2 of them, enclosed in green. And so the problem was that we counted the overlapping outcome 5 twice, because 5 is both an odd number and it is also greater or equal than 5. And so since in the original calculation we counted any outcome in the intersection of A and B twice, what we need to do to correct this calculation is to subtract any outcome in the intersection. In this case, there's only one outcome, and so we subtract 1 divided by 6. And this is now equal to 4 divided by 6, as it should be. And so the rule to calculate the probability of A or B is the following. The probability of A or B is equal to the probability of A plus the probability of B minus the probability of the intersection of A and B. So this is the probability of any outcome that is both in A and in B. So in particular, notice that in the case where the intersection of A and B is empty, meaning that A and B don't overlap at all, then this last term here becomes 0. And so when A and B have an empty intersection, we say that they are disjoint. And so in this case and in this case only, we have that the probability of A or B is equal to the probability of A plus the probability of B. Otherwise, one has to subtract the probability of the intersection of A and B. And so you should take a moment to convince yourself of this observation. Now, you don't need to remember this formula by any means, but the moral of the story and the takeaway is that when you calculate the probability of an event, you should make sure not to count any outcome twice. So as long as you have a way to calculate the number of outcomes corresponding to an event once, then you're fine. Very good. So here's another exercise for you to test that you understand what we just talked about. So the exercise is the following. You shuffle a deck of 52 cards, and again you draw the top card. Now, what is the probability that this card is either an ace or a heart? And again, I encourage you to pause the video, work on this exercise until you're happy, and only after that move on.